everyone, my name is Kevin, and today we're going to talk about radioactive elements and common substances. Uranium. Uranium's primary isotope or element's variation is uranium-238. It can be found on the Earth's crust. It can be used for nuclear weapons and energy. It is arguably one of the most dangerous elements due to its radioactivity. Next, thorium, named after the thunder god Thor. Primary isotope is thorium-232. It's used for the future of science of technology. For example, used for nuclear duty or things that work using nuclear reactions or like that. It does not go under nuclear fission like uranium, which is thorium-232. But it takes in a neutron and turns into uranium-233, which can be used in nuclear reactors. Next, potassium. Potassium's primary isotope is potassium-40. It is less radioactive than most other elements because due to its small radiation, it doesn't have any industrial applications. It can be used to age earth-based materials, for example, trees, rocks, and things like that. Next, carbon. Carbon-14 can be used for radiometric dating. C14, okay? It's living organisms absorb carbon-14, allowing scientists to estimate the age of organic material. Carbon, alright? Next, radon. Its primary isotope is radon-222. It's found from the decay of uranium and thorium. Although this is a noble gas, it is still radioactive. It can accumulate in homes, buildings, and other enclosed spaces, which is quite dangerous. Polonium. Its primary isotope is in this part, the isotopes are not primary, okay? They are discovered by Marie Curie and Pierre Curie. First, when being discovered, they looked harmless, but the whole world shocked when Alexander Litvinenko died due to polonium poisoning. It has a few industrial uses, for example, in treating nuclear reactions. Next, radium. Its primary isotope is radium-226. Exposure to radium is dangerous because just like the name radium, it also means radioactive. Get it? Next, 8. Technetium. Its primary isotope is technetium-99m. It is used for medical treatment due to its short half-life. It has unstable isotopes and its rarity limit its industrial applications. This has no stable isotopes, okay? And that's why all of its isotopes are radioactive. Promethium. Primary isotope is promethium-145. Promethium-145 can be used in nuclear reactors. Promethium has no stable isotopes and has limited applications. For example, self-lighting signs. It can be used in atomic batteries and spacecraft because it's energy that the heat and radiation produce. Strict regulations are needed in handling and disposal because it can cause severe health and environmental risks. Next, americium. Well, americium's primary isotope is americium-241. Americium is used in smoke detectors because of its radiation emits particles that allow it to trigger the alarm in smoke detectors. An intriguing element for scientists to study. Next, californium. Its primary isotope is californium-252. It can be used in neutron radiography. It is used for medical treatment like cancer, where tumor cells are bombarded with neutrons to force nuclear reactions. And suddenly, bye-bye you tumor cells. Okay, you get loose. You're the loser, cancer. Kind of like that, okay? Next, tritium. It is an isotope of hydrogen, which is H3. It has many practical uses. Well, for example, it can be used for exercise and watches because it has a self-luminous property, meaning that it can create light on its own. Well, you haven't ever heard of a stick that can glow in the dark? Well, that stick, inside the stick, might contain something kind of like a substance, and that substance can create light on its own, which is self-luminous. Now you know what that means. Next, iodine-131. It is an isotope of iodine. It can be used in medical treatment, especially in nuclear medicine due to its radioactivity. It can be used in radiography, sterilizing, or cleaning different materials. Next, cesium-137. Cesium-137 is an isotope of cesium, an alkaline earth metal. It is quite dangerous, especially in long exposures because of its really long half-life. It is so reactive that it could even eat through glass. So after this video, you can see all of the elements in the periodic table and the common substances that are radioactive and you should take care of. And also, you could also see their uses too. So, if you like it, then please subscribe and like our video. And don't forget to miss any of our latest videos. See you!